This is the story of Mariner 1, a space mission that collapsed because of one small and avoidable mistake.
Destruct command. Repeat, destruct command.
It was a massive setback because at the time, America was riding high. World War II was won, the economy was soaring, and after decades of struggles, peace and prosperity were closer than ever.
Cars, radios, cordless electric irons, consumer goods of all kinds were coming off the assembly line.
But across the ocean, the Soviet Union had other plans. A newer, colder war was heating up. Space had turned into a battleground between communism and capitalism.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
And every mission carried a message. We're faster, richer, and smarter than you. Success in the sky was proof that one system was better. Mariner 1 was supposed to be America's moment. Instead, one tiny mistake almost cost them the space race.
Space is open to us now, and our eagerness to share its meaning is not governed by the efforts of others. We go into space.
It's August 1961. President Kennedy stands before Congress and declares a fight amongst the stars.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Two superpowers, two visions of the future, and only one of them can claim the ultimate high ground: space. The Soviets had drawn their first blood. In 1957, they sent the first ever satellite into space. Then just 4 years later, they sent the first person up there as well. America is jealous.
It's frightening. We should find out what they're doing that we're not doing. And we should do something about it very quickly.
Russia's getting into space really bothers me because it's making the Cold War between Russia and the United States, more intense.
They're struck by how these successful missions created a sense of unity, purpose, and pride among the Soviets and all their supporters. They want to capture that feeling back home. Even though President Kennedy wants to shoot for the moon, NASA knows that's just not realistic at the moment. So they set their sights on Venus. It's one of the closest planets to Earth, it's never been explored, and America believes it might have Earth-like secrets. But they're playing catch-up. The Soviets have been trying to reach Venus for years. So Washington makes two things clear to NASA: move fast and don't lose. Everyone inside NASA hears the battle cry, and for 11 months straight, everyone punches into work with a mixture of ambition and desperation. The goal is clear: make sure Mariner 1 is ready to launch by July 1962. Washington is watching, the world is waiting, and time is running out. Cape Canaveral is a pressure cooker of tension and anxiety. The race is on, and mistakes are easy to make. So what actually went wrong? Well, it came down to two major failures in the rocket's guidance system. Together, they created the perfect storm. Let's break it down. The first problem was in the hardware. The rocket had a beacon that sent data back to Earth, critical information about how fast the rocket was moving. Think of it like a speedometer sending constant updates to mission control. But this beacon started glitching, spitting out false speed readings. Now, normally, this wouldn't have been a disaster. The code was designed with a safety system to catch and ignore these kinds of faulty signals. But here's where the second problem came in: the software. It all came down to a missing character in the code. See that line above the letter? That's called an overbar, or sometimes a hyphen. The guidance code was missing this tiny symbol, and it turned out to be crucial. It was supposed to tell the computer to average out the speed data and filter out any random numbers. Either problem alone wouldn't have doomed the mission, but together, they created a critical failure. The beacon was sending bad speed data back to Earth, and since the code was missing this one crucial character, the computer couldn't tell these numbers were wrong. So it started making course corrections to fix a problem that didn't actually exist. The cruel irony was Mariner 1 was on track for Venus, but each correction pushed the rocket further off course. The guidance system was essentially fighting a ghost. Once they realized the new flight path put human lives at risk, the situation became critical, and 290 seconds into the flight, the range safety officer made the call. The rocket had to be destroyed. But how did NASA not catch the mistake? To figure that out, let's step into the world of 1960s programming. It starts with mathematicians actually writing out complex equations by hand. Every symbol, every number is noted down on paper first. Then, these equations are translated into a language called Fortran. Now comes the part that might shock modern programmers. Each line of code had to be punched onto individual cards, actual physical cards. Each one had 80 columns, and a single column was one character of code. Finally, hundreds of these cards are fed into a machine that turns them into binary, just so the computer can understand it. Today, we can write, test, and debug code in a couple of minutes on a single computer. But back then, programming involved a ton of manual work with very few checks, and each step introduced even more complexity. Bad documentation led to sloppy handovers between teams. There weren't any tools to simulate code and catch missing characters either. So once you had immense pressure, tight deadlines, and the weight of national expectations, errors could easily slip through. And what's worse is that they wouldn't be caught until the code was run in a real-world, high-stakes situation. And somewhere in this maze of manual work, a tired engineer made a critical mistake. They missed the overbar, the one symbol that would have told the code to ignore the problematic data. And that tiny error was faithfully translated, punched, and converted into code, creating a butterfly effect that took down Mariner 1. But any embarrassment was short-lived. Remember how at the start I said this mistake almost cost America the space race? Well, it turns out NASA had Mariner 2 on standby. That's right, NASA built a backup, just in case something went wrong.
It was offset a little bit by our knowledge that we had another one to go. Maybe we could resurrect things.
With the software problem corrected, Mariner 2 lifted off and began its 3.5-month journey to Venus.
It's almost like Mariner 1 was a test flight. So after blowing up their first spaceship, NASA moved fast. They treated the double failure as a learning opportunity and adapted and fixed things. They debugged the code, upgraded the speed beacon, and recalibrated every single system. Just 66 days later, they launched Mariner 2. It was a massive success. Mariner 2 was live for over 100 days, collecting new insights about Venus and space. NASA confirmed that Venus was hot, had thick clouds, and solar winds were real and constant. More importantly, America beat the Soviets to the punch by 5 years and became the first nation to explore another planet. But it was expensive. The failure of Mariner 1 cost NASA roughly $180 million in today's money. The value, though, that might have been priceless. NASA learned a ton from Mariner 1 and 2. Without them, they wouldn't have improved their workflow so quickly. They created automatic code analysis, built-in hardware redundancies, and ran mission simulations to prepare for potential issues. These lessons were key in the strategy and success of the Apollo program, which put a man on the moon and helped America win the space race. Mariner 1's failure was so influential that NASA's next director kept a framed hyphen behind his desk. Mariner 1's legacy leaves us with some tough questions. Did NASA move too fast? At first glance, the evidence seems hard to ignore. A multi-million-dollar rocket destroyed by a missing symbol, a mistake so small it could fit between these words. Lives were at stake and taxpayer dollars went up in flames. Some people might argue that more careful planning should have prevented it. But step back, and you might see a different picture. NASA was racing against the Soviets for tech supremacy. Mariner 2 wasn't just a backup, it was a strategy. Mistakes were likely, so they planned for them. Fast forward 6 decades, and we see SpaceX following a similar playbook. Their early Falcon rockets went up in flames. Starship prototypes left scrap metal across Texas. Yet, each failure brings them closer to success. Is this a reckless approach to innovation, or is it something else? You could call it a calculated dance between caution and ambition, where the cost of moving too slow might be greater than the price of occasional failure. Maybe the real question isn't whether NASA moved too fast, but whether real innovation demands this kind of boldness. When you're pushing the boundaries of what's possible, is perfection the enemy of progress?